gentlemen, I'm John.
I'm Whitney.
And we're running some concrete mixes. But in between, we wanted to answer a quick question from our YouTube folks. Thanks for subscribing. Before we get into it, don't forget to subscribe, ding the bell for notifications. And this month only, we'll be giving out a free piece of glow-in-the-dark concrete. I don't have any here. I don't really understand the whole concept, but Whitney
I feel
does.
like it's fairly straightforward.
It makes zero sense.
For most.
Okay, so we gotta answer this question. Ding! Question from El Khalil. El Khalil, hope you're doing well, enjoying the computer. Your studies are going well too, right? He should be towards the end of his PhD.
Right.
Want to know how the thesis is going. Listen, be tough. You got this, buddy. So, question from El Khalil. Ding!
Oh my gosh, baby, your dings are so loud. Awesome test, I like it. But why didn't you slice the specimen with the electrical saw? So
what El Khalil is referring to is a video that we did on a modified version of ASTMC 1585, which is a capillary absorption test.
Wicking.
A wicking test. So what that test does is it's basically a mass gain test.
Right.
Over 7 days, you're working with a dehydrated piece of concrete, and you're identifying the primary and secondary absorption of the water into the concrete. And like I said, you're just weighing it every so often. And it's sitting on top of water. The way we changed it is we put two different types of crack in there. Mm-hmm. Either cracks that you can't see, which is fatigue cracks, where we put our sample, which is a 2 or 3 inch diameter puck that's 2 inches tall. We put it into our compressor machine as if we were doing a split tensile, cut it on either end, and really create the localized event for crack elongation. So we crack it first, all the way full, to find out where it's going to fail at. Mm-hmm. We do that for 3 samples and we put them back together, and then we do fatigue cracks. And then we have a virgin sample that has no cracks. So to answer El Khalil's question, El Khalil, we're trying to create cracks. We're trying to simulate what you're going to see in the operational world and then test it from there. If we were going to make a clean cut, we can actually have some contamination from the saw that we're using. But more importantly, it's not a realistic crack. That's not... Yeah, and the cracks that we're trying to simulate are either the fatigue cracks from, 10 loading, 40% of what the failure load was, and then the all the way full crack is where the failure was, and then we glue it back together, create that window all the way through the concrete of where we're just creating that capillary absorption from the crack, or the fatigue crack. So... yeah, more realistic. That's why we didn't do that.
And that's generally what you're trying to do in the lab, is create some accessible version from the lab to the field. Like, you're trying to simulate what's going on out there. So, and there are a lot of methods that would make it easier, but we're trying to get as good of an idea as we can as to what would actually happen out there.
And then when we saw cut it and put the pieces back together, so we did go down that route, the crack that we developed was not the hairline crack, and I can't remember what ACI that defines a hairline crack, but that's 1/32 of an inch, which is around 0.75 millimeters. And that's the type of crack that we're trying to seal and heal. And that's what the crack that we developed from sawing it, just with the blade, you get a very wide crack, much bigger than a millimeter, and that you're not going to get that capillary absorption effect. And your surface additives aren't usually protecting cracks 1 millimeter to 2 millimeters wide. So, yeah, hopefully answered your question. Thanks again, El Khalil. You're absolutely awesome. We appreciate it. So, go concrete!
Beat asphalt.